held on June-July 2019. So this is the question. Module 2 will be covered in covered fast Fourier transform. It contains the question number 3 contains 3 sub questions A, B, C. First question is what are FFT algorithms? Explain the advantage of FFT algorithm over the direct computation of DFT for a sequence X of n. Second question is what are the differences and similarities between DIT and DF FFT algorithms. And the third question is find the 8-point DFT the sequence X of n is equal to 1, 2, 3, 4, 4, 3, 2, 1 using DIT FFT radix 2 algorithm. We can go to the first question. What is FFT? Everyone knows that FFT stands for fast Fourier transform. It is an algorithm used to compute the DFT of a given sequence in a faster manner. Here we are using the divide and conquer approach for the decimation of the given sequence, and this is based on the decomposition of an endpoint DFT into a successive smaller DFTs. Coming to the advantages of FFT over DFT, as we know already, we solved many problems. FFT is more efficient than DFT. And coming to the second advantage, we know that complexity of computations can be reduced significantly than DFT. How complexity of computations can be reduced significantly? We know that in direct computation, the number of multiplication is given by n square, whereas in FFT, the number of multiplications can be given by n by 2 log n base 2. Okay. Similarly, we know that the number of additions in DFT is given by n into n minus 1, whereas the number of additions in FFT is given by n log n base 2. These are formulas used to find the multiplications as well as additions in case of both FFT as well as DFT, and from the computation we know that FFT is more efficient and more faster than DFT in several times. Okay, so and implementation of FFT is very easy rather than DFT, and we can save a lot of memory because we know the number of computations will be reduced compared to DFT, so we can save a lot of memory in FFT compared to DFT. So coming to the second question, what are the differences and similarities between DIT and DIF FFT algorithm? As we solved problems on both the categories, we know. So what is the radix 2? Radix 2 stands for any FFT, either it in DIT or DIF, we can take the given length has to be decimated with a base of 2. It is called as radix 2. Suppose if the given length n is equal to 8, we can take that 8 as, with radix 2 means the 2 with the base, we can take 8 to be written as 2 cube. So we can write it contain number of stages will be 3 with the base 2. So this is called as radix 2. Similar in case of DIF FFT algorithm. Coming to the first point, here in DIT FFT algorithm, where time domain sequence is decimated, whereas in DIF FFT, the frequency domain sequence is decimated as the name indicates. And we know generally, while solving the problem, we notice this. In the DIT FFT algorithm, the given input sequence X of n will be converted into bit reversal order, and your output should be normal order. Where it is reverse in DIF FFT algorithm, the input is in normal order, whereas the output is in bit reversal order. And similarly, we know at each stage of decimation, the phase factors are multiplied before the add and subtract operations. Okay, we know that the butterfly diagram, we observed that the 12 factors are multiplied before the add and subtract operations. Here in FFT, DIF FFT, the multiplication can be done after the addition and subtraction. We know that a plus b into omega n power 0 or a minus b into omega n power 0. Here it is not like that. A minus b into omega n power 0 or a plus b into omega n power 0 or a plus omega n power 0 into b, like that. Okay, here the multiplication should be within the operation itself, it is there. Here after the addition and subtraction we will have the 12 factor multiplication. So the value of n should be expressed such that n is equal to 2 to the power of m, and this algorithm consists of m stages of computation. As I discussed already, if you take length n is equal to 8, so it is radix 2 means it would express the 8 as base of 2, so therefore we can write 2 to the power of 3. That 3 indicates the number of stages involved in the algorithm for the computation purpose. Similarly, here also it is same. Okay, coming to the arithmetic operations, that is addition and multiplication. So the number of complex addition is given by n log n base 2, and complex multiplication is given by n by 2 log n base 2. That is same in case of even DIFFT algorithm also. So these are the similar, 4 and 5 will be similarities, both are same, whereas 1 and 2, here we are decimating the time domain sequence, we are decimating the frequency domain sequence. In DIT we will have the input is in bit reversal order, whereas output is in normal order. Here what about in DIF is the input is in normal order, the output is in bit reversal order, and we rewrite the bit reversal order output into normal order for the final calculation purpose. And multiplications will be before the addition and subtraction operations. Here after the addition and subtraction operation, multiplication takes place. Coming to the third question, that is compute the 8-point DFT of the following sequence by using DIT FFT algorithm. We know that DIT FFT means decimation in time fast Fourier transform algorithm. The given sequence x of n is equal to 1, 2, 3, 4, 4, 3, 2, 1. The given sequence x of n, as we know that there are 8 samples are present here. So the method is DIT FFT algorithm, and here the number of samples are 8. So therefore the total length of the given x of n is equal to 8. So we know that for n is equal to 8, we can use maximum 4 Twiddle factors in the entire calculation purpose. In all the 3 stages, we are using 4 Twiddle factors. We already told we are using radix 2 here. Here it is not mentioned. So it is default. We are using radix 2 DIT FFT algorithm. So therefore we can write n is equal to 8. Okay, 8 is equal to 2 to the power of 3. So there are 3 stages are present. So in entire all the 3 stages we are using maximum 4 Twiddle factors. We know that for n is equal to 8, omega 8 power 0 is equal to 1. Omega 8 power 1 is equal to 0.707 minus j 0.707. Omega 8 power 2 is equal to minus j. Omega 8 power 3 is equal to minus 0.707 minus j 0.707. These are the 4 Twiddle factors we are using. Generally depends upon the number of stages in the computation purpose. And what we are doing here, we know that already in DIT FFT algorithm the given input x of s in normal order. So before solving the problem, we rewrite the given input x of n in the bit reversal order. So how to write the bit reversal order, you know that. So decimal number 0 to 7 can be write it in binary, and you reverse a binary sequence, and whatever the number is getting equivalent decimal number, that will be a bit reversal output. So therefore when you interchange 0, you will get 0 itself. When you interchange 1, you will get 4. When interchange 2, you will get 2, 6, 1, 5, 3, 7. These are the bit reversal order inputs. So the corresponding sequences will be taken here. So corresponding samples are 4, 3, 2, 2. Here 1, 4, 3, 2 and 2, 3, 4, 1 are the corresponding bit reversal order samples. So this will be used for the input. Coming to the first stage of the decimation, here there are 3 stages, as we know that the length n is equal to 8. There are 3 stages are there present here. Here we are using DIT FFT algorithm. First we are using 2-point DFT. Then we are using n by 4, that is n by 4-point DFT. Then we are using n by 2-point DFT. Third stage. So first stage we are using 2-point DFT. So there is a minimum order. Okay, minimum points required is 2 points for any butterfly diagram. So this is the first stage. Here we can write the input in bit reversal order. 0 is equal to 1, 4 is equal, x of 4 is equal to 4, 2 is 3, and x of 6 is equal to 2. Here 2, 3, 4, 1 are the 8 inputs. And from the stage 1 output, we know that, so x of 0, the stage 1 output is given by here x1 of 0, x1 of 0 or f1 of 0, whatever it may be you take. X1 of 0 is equal to, you can write, you see, so this 1 as flow always, okay, same manner. So you see the second point connected with this is 4. While it is traveling, it is multiplied with the Twiddle factor as we discussed in the differences. So omega 8 power 0 is 1. So 4 into 1, 4 is traveled towards this particular point. So we'll get 1 plus 4 is equal to 5. So this is the output of x of 0. Similarly, we can find all the points, okay, all the outputs. We'll get similarly what is x of 4. X of 4 is, you see here, x of 0 is traveling here, x of 0 and x of 4. So this point is given by x of 0 minus x of 4. Why it is minus x of 4? This 4 is multiplied with 1, it becomes plus 4. When it is travel, it is multiplied with minus 1, so it becomes minus 4. So 1 minus 4 which gives rise to minus 3. This is the answer. Similarly, we can calculate all the points. We are getting output of first stage is 5 minus 3, 5 1, 5 minus 1, 5 3. One more input as here also 10. This your fifth input will be 10. This is your 10. Then, so what is the output here? This 10 is traveling towards the here. This is the final stage is given by x of 0. This is the frequency domain sample. So 10. So what is the other point connected to this is this fifth point. Okay. So therefore this 10 is multiplied with omega 8 power 0. Omega 8 power 0 value is 1. So 10 into 1 is 10. So this 10 is traveled toward this side. So 10 plus 10 is equal to 20. 20 will be the solution for the final stage, and this output will be in normal order, where the input is in bit reversal order. Similarly, we will get x of 1, x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7. And we know already by using the complex conjugate property, when given sequence x of n is real number, so we no need to calculate all the points. Okay, once you find the 4 points, okay, the next 4 points will be the complex conjugate of first 4 points. You see, x of 1 is complex conjugate of x of 7. Similarly, x of 3 is complex conjugate of x of 5. And 2 and 6 values are 0. Okay, we know this already because whenever the sequence is real number, so we can verify the answer easily because of the complex conjugate property. This is the final output of the given DIT FFT problem. This output will be in normal order, and we have to write x of k is equal to, write the order in the fashion 0 to 7. Okay, go to the next question, that is question number 4. Question number 4 contains find the 4-point circular convolution of x of n and h of n given using radix to DIF FFT algorithm. You can observe this question. So here there are 2 diagrams are given. One is with respect to x of n and another is one with respect to h of n. We know the circular convolution. What is the meaning by convolution? Convolution is nothing but multiplication of 2 time domain sequences. Here there are instead of given sequence, they will give the diagram. So what we noticed here there is no points are mentioned. The magnitudes are not mentioned in the given problem. The question paper setter has forgotten to put the magnitude of the points which is given in the problem. So therefore, as we practice, we know that you see the magnitudes level here, all the magnitude levels are same. So you can assume better for simple understanding purpose, we can assume x of n is equal to 1, 1, 1, 1. For n is equal to 0 to 3, the magnitude is given by 1, 1, 1, 1. Similarly, here also observe here 1, here 1. Here x of 1 is, h of 1 is 0 and h of 3 is 0. So therefore, what is the sequence of h of n? H of n sequence is given by 1, 0, 1, 0. So this is the corresponding samples for x of n and h of n for the given diagrams. So I am assuming this for solving the problem. In the question paper solution also they are clearly mentioned. For above question number wrong, so solution has been uploaded in the scheme. The correct solution will be given below. In the scheme also they have assumed the same values 1, 1, 1, 1 and h of n is 1, 0, 1, 0. If you assumed any value, suppose if instead of 1 you can take 2 and perform the convolution and getting the answer, you will getting full marks for this. Okay, for simple purpose we are assuming all the magnitudes are same. Simply we will take and assume the value is 1. Similarly here also we are assuming 1. Here the assuming it is 0 point, obviously it is 0, so we will get 1, 0. So use x1 of x of n is 1, 1, 1, 1 and h of n is 1, 0, 1, 0, and we know that here the length n is equal to 4. Here the length n is equal to 4. We know the condition for circular convolution. If you want to perform circular convolution, the length of both x of n and h of n should be same. So there is no problem. We can continue the circular convolution for the given sequences directly by using radix to DIF FFT algorithm. We know how to perform convolution. It is multiplication. So which method? Radix to DIF FFT algorithm. So we can go. So we can take x of n, we take h of n, and given method is radix to DIF FFT algorithm. We know how to perform convolution by using Stockham's method or DFT IDFT method. Same procedure we are applying here. Take the given sequence x of n. So DIF FFT algorithm, you know DIF FFT, DIF we are using here. So the inputs are in normal order. the outputs are in bit reversal order. The outputs are in bit reversal order. So while writing the output, you should write the output in normal order. So whatever the obtained output is in bit reversal, so write the output in normal order. We will have 0 to 1 and 3. So rewrite it in normal order. Similarly, how to perform 4-point DFT for DAF, you know that. So we are doing the 4-point first, then we do with the 2-point. So take 1 1 1 1, and we know that multiplication factors will be, total factors will be present after the addition multiplication operation. So total factors will be present after this. Okay, so here 1 plus 1 is equal to 2. How we get this is this 1, that is 1 plus this one is traveling here, so 1 plus 1 is equal to 2. Similarly, another point, 1 plus 1 is equal to 2. Similarly, is here 1 minus 1. So here total factor is there. This total factor is given by omega 4 power 0. Why it is omega 4 power 0? Omega 4 power 0 is equal to 1. Similarly, here omega 4 power 1. So omega 4 power 1 is minus j. It is equal to minus j. So this one is traveling toward this particular point, and this one is traveling, it is multiplied with minus 1. So 1 minus 1 into omega 4 power 0. Omega 4, 1 minus 1 is 0. 0 multiply anything is 0. We get the answer 0. Similarly, here also this 1 is traveling here. So this 1 is traveling. So 1 minus 1 is 0. 0 multiply with any value, it will be 0. The value will be 0. Therefore, we are getting 0 0. So therefore, the final answer will be 4 0 0 0. Similarly, obtain the output for h of n. Here you get 1. Just a minute. Here 1 is traveling here. So similarly, other side 1 is traveling here. So we'll get 1. So 0 is the point, and 0 is coming here. So 0 minus 0, 0 multiply anything is 0, and other points also 0. And the second stage here, second stage, this 2 and this 1. So we'll have the total factor is 1 here, omega 8 power 0. Here omega 8 power, sorry, omega 4 power 0, because here n is equal to 4. Here also omega 4 power 0. Okay. Now this 2 is traveling, this 2 is traveling here 4, and 2 minus 2 into omega 8 power 0. 2 minus 2 is 0. 0 multiplying anything is 0. So omega 4 power 0 is 1. Okay. So here also 0 is traveling here, 0 is traveling here. So 0 plus 0, 0. 0 minus 0 also 0. Similarly, we are getting 2 is traveling here. Okay, at this stage, this particular point. And 0 is there. 2 plus 0 is 2. Similarly, 2, 0 multiply with minus 1 is 0. And the value of omega 4 power 0 is equal to 1. So therefore 2 minus 0 into omega 4 power 0, which is equal to 2 only. So similarly, other values are 0 0. And at the end we are getting x of k and h of k. Rewrite the output in bit reversal order. This will be in bit reversal order. So these are the output in bit reversal order. Already it is mentioned here clearly. You write the bit reversal output normal order. It is normal order. Okay. So 400 and 2020. And we know the DFT and IDFT method of finding the circular convolution. Once you find x of k into h of k, y of k is h of k into h of k. Multiply this point by point multiplication 8000 and take the IDFT of y of k, you will get y of n. Take IDFT of y of a, you will get y of n. So y of n is given by, you take again DIFT, apply DIFT. These are the inputs, normal order. The output is in bit reversal order. Okay, so 8 plus 0 is 8. Similarly here 0 minus 0 is 0. Here 8 0. Here this is point. Okay, 8 minus 0 is 0. Again here also it is missing omega 4 power 0. Here also omega 4 power 1 minus j. It is minus j. Okay. Similarly, you will get 8080. Similarly, you will get 8 plus 0 will get 8. Similarly, you will get 8 minus 0 will get 8. Similarly, you take here omega 4 power 0. Here also will get omega 4 power 0. Okay, so you get 8, 8, 8, 8. So we know that in IDFT formula, x of n is equal to 1 by n into x of k. So this 1 by n is the length of the given points. So length of the given point n is equal to 4 here. So take the bit reversal output of normal order, you will get 8, 8, 8, 8 only. So 1 by 4 into 8, 8, 8, 8, you divide it, you will get output, final output will be y of n is equal to 2, 2, 2, 2. This is the answer for the given problem. So this is the last problem. See here, given x of n is equal to n plus 1 and n is equal to 8 and determine x of k using DIF FFT algorithm. Already we solved the previous problem using DIF FFT algorithm for n is equal to 8. So this problem is same, but given the sequence directly, they will give the equation. From the equation we can calculate the samples x of n, and we can continue the same procedure. We know we derived derivation of DIF FFT algorithm, and also we solved so many problems on DIF FFT algorithm and apply the procedure, we'll get the answer. As we know here, the length is clearly mentioned, so take n is equal to 8. So it means that the given sample x of the given time domain sequence x of n contains 8 samples, and the equation is, instead of giving the samples directly, they will give the equation x of n is equal to n plus 1. And how to get the sequences means, for n is equal to, put n is equal to 0 to 7, you will get 8 samples. So 0, put n is equal to 0, 0 plus 1 is 1, put n is equal to 1, 1 plus 1 is 2, put n is equal to 2, 3. Similarly, last value, put n is equal to 7, you will get 8. So this is the corresponding point when you put n is equal to 0 to 7. This is the given point for x of n, 1, 2, 3, 4, 5, 6, 7, 8. And here the length n is equal to 8. We know that maximum total factor used for the problem is omega 8 power 1, 0, 1, 2, 3. And we know in DIF FFT algorithm, we can take the input in normal order and the output will be in bit reversal order, and rewrite the bit reversal order output into normal order once again at the final stage. So this is the problem, this is the method, okay, of the for n is equal to 8 point DFT for DIF FFT algorithm. In the first stage we'll have n by 2 point, here n by 4 point, here 2 point DFT. Okay, so here the multiplication factor is here. After the addition and subtraction operation, here total factors are multiplied here. So at the first stage we'll have n by 2. N by 2 means n is equal to 8. 8 by 2 is 4 point DFT. We'll have 4 point DFT. For 4 point DFTs we are using 4 total factors, 0 to 3. And here n by 4 point DFT. Here n by 2, n by 4. And the final third stage is, here is stage 1. Stage 1. Here is stage 2. Here stage 3. In the stage 1 you will have n by 4, n by 2 point DFT. So therefore 8 by 2 is equal to, we will have 4 point. We will have the 4 point DFT. Okay. So here n by 4 is here 2 point DFT, 2 point DFTs. Okay. Here stage 3 is 2 point DFT. So in the n by 2 point DFT we will have 4 total factors. N by 4 we have the 2 total factors. What are the total factors here? Here omega 4 power 0, they will take here 8 becomes 4 now, n by 4, therefore there you will take the value of 4 here. You take 8 also, no issue. Omega 8 power 0, omega 8 power 1, omega 8 power 0, because practice one methodology, we practice same in other problems also. Instead of 4 you can take n is equal to 8. 4 also no issue, because n is equal n by 4 point, instead of 8 they will take 4 point here. Similarly here 2 point DFT, they will take here n is 2. We practice only one methodology, so here also you can take commonly 8. So in the last stage you will have only one total factor. In the stage 2 you will have 2 total factor. In stage 3 you will have the 4 total factors. Okay. So do the calculations as per the previous problem. The final output we are getting in the bit reversal order, and rewrite the output in normal order. So this is the x of k for the given problem. Thank you.